And now it is a pleasure to introduce to you Dr. Robin Cotting. Thank you for joining us.
Thank you for having me. All right. So should I share screen now?
Yep, go ahead. It's all
All right.
yep, it's all you.
Thank you. Thank you so much. It's an honor to be here with all of you. I'm really excited to have the opportunity to talk with you about this topic. What we are going to do today is talk about 4 things. What is intensity? The strengths and limitations of standard protocols. 5 dimensions of intensity. So I'm going to unpack each of those dimensions. And then we're going to talk about how do you actually translate those ideas for how to intensify intervention using a database decision-making framework, looking at some sample data. So you should be able to walk away with some actionable items today. To begin, we are going to talk about intensity. So what is intensity? You can see that I have an image of a layered support pyramid representing an MTSS model on the slide. Our emphasis today is really on that top tier, referred to as intensive support. And there are some questions I'd like you to think about or reflect upon as we start to move through each of the components that we're talking about today. So feel free to think about them or reflect upon them. What does intensity mean to you is the first question. And the second question is, how is tier 3 differentiated from tier 2 in your systems? What does that look like for math intervention? Yeaton and Seacrest in 1981 suggested that by monitoring intensity, sometimes I refer to that as strength, integrity, and effectiveness for the duration of treatment, we can make appropriate mid-course corrections. And that's really what we're talking about with this group of students who is in need of something different than what we've previously identified. And we're going to walk completely through that today. So that means that student responsiveness to any intervention is predicated on a 3-legged stool. Effectiveness is impacted by the integrity with which the intervention is implemented and that intensity of that intervention. Unfortunately, we have limited definitions of intensity. So Barnett and colleagues suggested that even if we think about an MTSS model, at the time he was writing about it, it was referred to as RTI, or response to intervention. It relies on accurate decision rules between and within tiers and the ability to judge intervention intensity. So even though we've talked about intensity, you can see on this graphic is illustrated in a different way than in that pyramid I showed you previously. It's a widely discussed conceptual idea with little evidence existing that actually examines intensity and the variables specifically, with no clear definition of this construct. So as a result, we often default to defining intensive intervention as one-to-one service delivery. So I wanted to start our conversation about what is intensity in order to address this idea that intensity equals one-to-one service delivery. So I am here to tell you that individualized supports, intensified supports, is not individual. So intensive support is not about one-to-one service delivery or individual support. It is about individualizing student supports based on their needs. So what it means that we should be doing, and what our conversation will be about today, is diagnostic assessment, database problem solving and decision making, and individually designed supports. It is just as effective and more efficient to use small groups for service delivery. The point is that we are tailoring that support to individual student needs, not that we're providing one-to-one intervention delivery. Okay, so now that we have intensity defined, we can talk about standard protocol interventions. And I mentioned at the top that we were going to talk about the strengths and the limitations and why we need to think about something more when we talk about identifying individualized service supports for students. This is important because the primary approach in schools is to use a standard protocol intervention to deliver services to students that are having difficulties. So these are the programs that schools and probably you are often talking about and trying to locate. There are strengths and limitations to this approach. When I was in graduate school about 2 decades ago, the field was talking about the standard protocol approach and the problem-solving approach. We obviously moved forward when we went into this idea of MTSS with the idea that we are going to use a standard protocol approach, and that has largely been adopted. But now we've come full circle back to realizing that for students with the largest gaps between current and expected performance, we need to use assessment and data to determine the learning challenges that students are experiencing and then match their instructional approaches accordingly, which requires a problem-solving approach. So it's really a joint approach that we're going to end up talking about. Standard protocols are great because their goal is to provide research-validated treatment protocols. When you get a standard protocol intervention package, it typically includes materials, assessment tools, treatment adherence forms, step-by-step protocols. And the advantage is that you, in theory, would have a better quality control of that delivery of the intervention that is more usable and more feasible. That's the benefit of the standard protocol intervention. Selecting the standard protocol intervention, however, is only one aspect of maximizing the probability that students struggling in math are going to benefit from receiving those supports. So the reason we choose a standard protocol intervention is because it has some level of evidence that we've been able to identify, and we are likely to see anticipated benefits from that intervention. However, not all children are responsive, and there is not always an intervention package that is feasible and usable and available. So on the slide here, you're going to see 3 places where you can locate those standard protocol interventions, see what the evidence is, and see if it works for your community. So one is What Works Clearinghouse, another is the National Center on Intensive Intervention, and the third is Evidence for ESSA. But if we actually take a look at the NAEP data, which I'm going to share with you now, and I'm going to walk you through these NAEP graphs. I have 2 slides. We've really failed to move the needle on students with the most intensive needs. So this graph represents the 4th grade 2024 math NAEP data. And you can see that there are 5 different data paths. The hexagon represents the 90th percentile at the top. The 75th percentile is represented by the square. The circle is the 50th. The diamond is the 25th. And the plus sign is the 10th percentile. So you can see this pattern. So what the highlight of this graph is looking at the year 2022 and 2024. The prior assessment is 2019. And then you can see the range of scores over time. So compared to 2022, the 2024 math scores increased by 2 points for that middle performing group, the circles, and by 3 points and 2 points respectively for higher performing students. Those are the ones that are in that blue box right now, the 75th and 90th percentile. So you can see there is a drop between 2019 and 2022, and then a slight increase in 2024. However, we can see that the scores for the lower performing students, the 10th and the 25th percentiles, were not different from those in 2022 and are significantly lower than in 2019. So you can see that decreasing trend. You can also see over time that there's really flattening of performance of these students. So these data suggest that, again, we haven't moved this needle on students with the most significant needs, and perhaps that standard evidence-based treatment protocol doesn't address the needs of all students, and really we need to be thinking about doing something more. This graph is just to illustrate that the 8th grade data is very similar in nature. And again, you have these same 90th percentile, 75th, 50, 25th, and 10th. And then you can see if you look at the plus sign and the diamonds at the bottom of the graph, what a significant decrease we are observing. So once again, we are seeing that same pattern. What we need to be doing is individualizing instruction. We're going to do that 4 ways. We're going to clearly define the learning challenge. We're going to collect data. We're going to generate reasons for the math learning challenge, and we're going to link those reasons to instructional intervention plans. And so that's my goal today, is to help you identify what's the process for doing that, and then how am I actually going to make those links. So when we implement instruction, we're going to be able to better match the instructional solution to the learning problem than if we use a standard protocol alone. So it's worth repeating that selecting an intervention with the best available evidence is only one aspect of really maximizing that probability that students struggling in math are going to benefit from the received targeted supports. So some of you may be familiar with this term. The process that we're going to unpack and unfold today is referred to as data-based individualization, or some refer to it as data-based instruction. You can find more details about it on the National Center for Intensive Intervention, and the website is listed below here. But roughly, the process involves a couple of components. The first is that validated intervention program, that standard protocol. What is the standard protocol? We are going to start with that. We want to make sure we're making a good choice based on the clearinghouse evidence available to us. We are going to monitor student progress. That's what this graphic on your slide is telling you. And if students are non-responsive, that's where that minus sign is located on your graphic in front of you. You are going to engage in a 3-step process. You are going to look at diagnostic data that we're going to unpack a bit today. I'll unpack it a lot more tomorrow in my session. We're going to talk about intervention adaptation, which is the focus of our conversation today, and then progress monitoring. And you can see that if students are responsive, you continue. If they are non-responsive, you go back to the data and then adapt the intervention again. So we are talking specifically about the intervention adaptation process using 5 different dimensions today. So what I want you to be able to do is know what those dimensions of intensity are that we need to individualize the intervention and when to use them. Okay. So as you see, we're going to still begin with that standard protocol intervention, and we're going to add more. Just a quick note about standard protocol interventions. We want to make sure we are using interventions that have effectiveness, that demonstrate that they work, and that they include high leverage evidence-based practices. High leverage practices are the most critical practices that, when used frequently, have been shown to improve student outcomes if implemented. So we're going to get more bang for our buck if we are using in a standard protocol program with good ingredients. And those ingredients are those that we know are effective for students who need more when their progress is low, slow, or absent. So one way to identify an intervention protocol that has those practices is to use the IES practice guide that just came out in March 2021, so still relatively new resource for students struggling with mathematics, particularly at the elementary level. So this is a summary of all of the data that exists. So these are 6 items. The first 3 are that we want to make sure students, the program has systematic, explicit instruction. It explicitly teaches math language in clear and concise terms, and uses a well-chosen set of concrete and semi-concrete representations. We're going to talk more about that as we move forward, because that's also an opportunity for us to individualize supports. We also want to make sure that that standard protocol intervention talks about using the number line, has word problems that focus on that structure of the word problem, and engages in, or has opportunities for timed practice in order to build fluency. So the emphasis is not just on accuracy, but is also on fluency and generalization. And as we've talked about before, we want to make sure that intervention is effective. So you want to use something that is effective and representative of your school population. So remembering, when we talk about these clearinghouses, sometimes that can get confusing. Peer review is still the gold standard, a journal article. We need a body of literature to make something evidence-based. So a body of literature is that peer-reviewed literature. And then when we have a lot of it, we can call it evidence-based. And again, these are the sources that we've already talked about in terms of identifying what is that effective intervention, and is it good for your population represented in your school system. So that's part 1. But the part we're really focusing on today is how do we make those database decisions to individualize instruction. So let's take a look at this example graph. On the graph, you will see blue data markers for Hayden's performance during baseline, which represents general classroom instruction. And then when given a standard protocol math intervention, the first part of that data-based individualization process. You can see the orange dashed aim line or goal line and the star indicating the goal that Hayden is anticipated to achieve after so many intervention sessions. The point of this graph is really to illustrate the lack of progress Hayden is making. And again, if we look at those blue square data markers in comparison to the orange aim line, when receiving that standard protocol math intervention, we can see that Hayden is not responding to this intervention. So the things you might be asking yourself are, is the skill too hard? Should we teach prerequisites? Is the student motivated? Should we add reinforcement and self-regulation? Does the student need more practice? Should we increase frequency? And does the student need more help? Should we provide more explicit instruction, modeling, and guided practice? And what I'm suggesting to you is that we can actually take these common challenges that students have and identify a model or a framework looking at those 5 dimensions of intensification. We're going to take those questions and then we're going to look at our data. So you might have many different sources of data. These are some examples here. With these diagnostic tools, we want to gather detailed and specific information on what students know and what they don't know. So we can use things like student and teacher interviews, curriculum-based measurement. So I'll talk about that periodically throughout our session today. Unit tests, observations, fact assessments or concrete representation and abstract assessments. And again, I'll talk more about that in my session tomorrow, and task analysis. So we want that data that we're collecting to provide detailed and specific information. And we're going to use that detailed and specific information to help individualize our services. So collecting data on the Math Learning Challenge requires us to consider what to teach along with how and when to teach it. So I'm going to start with the what to teach, and then we're going to get really into the how and when. So one of the first things I want us to reflect upon is the common math difficulties for students. There are, by understanding common math difficulties for students, we can also discern what skills we should focus on that connect to key math learning outcomes. And so for K-8, the goal is algebra ready. Bryant and colleagues generated a list of 29 math behaviors associated with learning difficulties and disabilities. And students can exhibit one or two of these, most exhibit many of these. And so these are some common examples: poor recall of number combinations, not understanding the commutative property, ineffective counting strategies, regrouping errors, misaligning numbers, trouble with the meaning of symbols, difficulty solving word problems, difficulty implementing a plan to solve the problem, trouble identifying tangential information, not understanding what is being asked in the math question, the math language itself, which we've talked a little bit about, failing to check work. What is really helpful is that they were also able to identify what are the most common math difficulties among this broader list. And it is solving word problems, multi-step calculations, math language, checking work and answers, automatic recall of basic facts, and fractions. And by knowing that, that helps us to refine how we're going to support students. So the idea will be to teach foundational skills first. So when we consider what to teach, we want to aim to teach those foundational skills first and build proficiency with these skills. So in this figure, you're seeing an illustration of, we identify using our screening data, we kind of already know maybe where the gap is. It's within whole number knowledge or within rational number knowledge, perhaps it's in both. And then within that, where are the gaps? Is it in the numeracy understanding, number operations, word problem solving? And that's similar across both whole number and rational number knowledge. So that's a little bit about the what to teach. We're going to spend most of our time today talking about how and when to teach it. And we have a few considerations when we think about how and when to teach the appropriate math skills and concepts to students. And that's really about the instructional strategies. So first, students in need of intensive individualized support require changes in frequency and duration of instruction, increased motivation and sustained engagement, smaller slices of the curricula that is more focused and has specific goals, and considers cognitive load, working memory, and learning retention. We also know that there are several common reasons that we can anticipate for why we observe students' lack of responsiveness. These include the student doesn't want to engage in the behaviors. And one of the things we need to know about is, we need to remember is that students that have a long educational history of struggling in math are less motivated to come to the table and learn math. And it's a struggle to get them to start. And we'll talk a little bit more about that. We also know that students may not have had enough practice. So it's really about more opportunities to practice, that they need more help in a specific way. They need more support, that potentially we are focusing on skills that are too hard and we need to go back to those prerequisite foundational skills, or that students haven't had the opportunity to do it that way before and therefore are having difficulty generalize their skills. So motivation, opportunities to practice, level of support, prerequisite skills, and generalization. So using what we know about matching instructional strategies to student needs, along with the common reasons For students' learning difficulties, we can organize our answers to the questions that we posed around Hayden's difficulties into 5 dimensions that can generate actionable steps to provide individualized support. And I will unpack each of these in the next set of slides. So the first is to adapt the intervention. We're going to add, alter, or change intervention components, starting with that standard protocol. We are going to increase dose, session length, frequency, or total duration. We are going to change our assistance. We're going to match instruction to the skill hierarchy. So we're going to consider where the student is on the hierarchy and how do we address their needs. Fourth, we are going to adjust the target skill. So slice back, look at those foundational prerequisite skills, break down tasks into small sections, or set new goals. And the last one is change grouping. So this one is going to be all about homogeneous groupings and smaller teacher-student ratios. So here are those 5 dimensions of intensity unpacked. We're going to start with adapting that intervention. So we're going to add, alter, or change those components. And we're going to talk about doing that in 2 ways. We are going to add, alter, or change academic components, or we are going to consider adding behavior supports and or self-regulation strategies. So first, we're going to think about adding, altering, or changing those academic components of the treatment package. So more opportunities to practice. You may have heard about this before. One of the things that we know is that opportunities to practice tend to be limited in our core curricula. They focus primarily on accuracy and minimize opportunities for timed activities and tasks. But when those opportunities are provided, they often fail to include immediate feedback to clear misconceptions, or the opportunities are masked or blocked instead of distributed. So we have a lot of things that we can do in our individualization of interventions in order to address this gap in our both core curricula and our standard intervention packages. We also tend to vastly underestimate how much practice is needed for students to master math skills. So Matt Burns and his colleagues have demonstrated, just looking at multiplication facts, that the average student in grade 3 requires about 8.5 opportunities to practice a single math fact in order to master it. And those are more simple math facts. Whereas students in that same grade, below average performing, require 11 opportunities to practice. So we need additional opportunities to practice, which means that we need to make those practice opportunities deliberate and productive. And we need to provide more opportunities for active engagement and high levels of teacher feedback and support. So that is the goal. I like to think about 4 aspects of practice. I'd like to think about guided practice, which is often teacher-led, includes demonstration and modeling, and think alouds while solving. So you're going to actually go through the process of what you're thinking when you're solving that problem and model that for students so they can actually replicate that. Providing skill drill, which I refer to as drill and thrill, skill in isolation. So it's really talking about how do we isolate those key skills. One of those key skills we know are math facts. So we can provide flashcards or incremental rehearsal, which is a specific intervention that uses flashcards. We can provide practice, which combines new with previous learning, so tasks and activities that integrate those previous skills. And then cumulative review, which integrates previously learned skills and concepts in games, in advanced problems, and in other forms of activities. So thinking about these 4 different types of practices is really helpful because we may need different types of practice for different skills or for different students. We can also add visual representation. We know that students who use accurate visual representations are 6 times more likely to correctly solve mathematics problems than are students who do not. We also know that students with math difficulties and disabilities do not use or create accurate visual representations. So we really want to be able to identify those appropriate visual representations and have students be using those visual representations. It allows us to integrate conceptual understanding by using these visual representations. We can think about aligning those visual representations with the types of problems that we are working on. Another way to adjust an intervention is to adapt those intervention components. Adaptations might include improving efficiency or simplifying procedures to align with the time and resources available. We might do that by isolating and layering treatment components to ensure that the most simple or parsimonious treatment is provided with only those active ingredients I was talking about before, the ingredients that we know when we use them are going to maximize the instruction that we are providing in our intervention session. So this example is specific to a doctoral student that I had who applied a word problem solving intervention that you see here, solving math word problems, to English learners, which included word problem solving components and multi-digit computation components. And what was she noted was that the students were not improving and conducted an error analysis to figure out why. And so when she did that, she learned that the students actually knew how to set up the word problems because the standard protocol intervention was very helpful at doing that. They also were able to regroup, but they did not know their basic facts automatically. So she added a basic facts intervention to build fact fluency and was able to get better results. It's also possible if there's a really complex treatment that's initially delivered, you could remove a component to improve student outcomes. So thinking about what are the components of the intervention and how does that map onto what your student is needing. Another way to think about adapting, altering, or changing that academic components of the intervention is to alter the task. So thinking about that to maximize opportunities to practice based on what you know. So thinking about utilizing concrete representations if you haven't been doing so, or two-dimensional pictorial representations, thinking about focusing on numerals. And again, in the way that we talked about before, does a student need the practice in isolation or practice in context of skills? Or is it the fact that we need to focus on the application component, like putting those skills into practice within a word problem? So let's talk a little bit more about using concrete, semi-concrete, and abstract representations. So using concrete, semi-concrete, and abstract represents three modes of representation. So obviously we have our concrete, which is three-dimensional, so use counters, chips, blocks, two-dimensional, which is typically pictures or diagrams or number lines, and symbolic representations. The idea traditionally was that you begin with opportunities to practice using manipulatives during guided and independent practice until the student is at least 80% accurate with 3 consecutive sessions of independent practice. And then you would move on to the two-dimensional component using that semi-concrete representations like pictures of objects. And once mastery is achieved there, then move to numerals, the symbols without manipulatives at all. So just looking at using those numbers. The current thinking, however, is that integration of those three with the goal of moving to full independence with numerals alone is really helpful. So if students are not successful with numerals alone, we can also think about moving back to semi-concrete or concrete representations. So thinking about the sequence of concrete, semi-concrete representations with the goal of moving to abstract or symbolic representation. Another thing that often comes up in our school systems, particularly as we're thinking about that feasible, usable, and available aspect of intervention delivery, is ed tech. And so what we consistently see is that ed tech apps and programs have been shown to have a range of small to moderate effectiveness when used in addition to good solid tier 2 intervention and core instruction. When students are assessed by that tool, they're placed at the appropriate level and are given exercises and ongoing assessments in a step-by-step sequence to move them forward rapidly as possible, and is connected to conceptual understanding. So if we are picking programs that are effective in those ways, we can get some small to moderate benefits. There are some caveats, though, that the research has started to demonstrate. So we've done some studies in this area, and my colleagues have done some studies, including Brian Ponce in this area as well, Gary Duhan. And what we have learned is a few things. This is what we know right now. When you use ed tech, we know that there are some strengths and some limitations. So when we provide paper pencil practice as opposed to ed tech, we know that paper pencil practice can improve computer-based calculation performance. So if students are required to perform calculation on computers, they can do that. And they also are good at paper-based calculations. However, when we are providing practice via computer, we are seeing that computer-based calculation performance improves, but not paper-based calculation. So it seems to be trapped in that modality of computer. We also were able to look at peer-based activities and compare them to paper, pencil, and computer. And we learned that peer-based activities like peer tutoring lead to more opportunities to practice than computer practice and more engaged time than computers. So we also want to think strategically about how we're using our educational tech apps. We want to know what they are and how we're going to be utilizing them. Okay. So that gives us a good example of how we can add, alter, or adapt our academic components of the intervention, thinking that we're starting with a standard protocol intervention to begin with, and then thinking about how to build those adaptations. The next thing we're going to talk about is how to add self-regulation and behavior supports. And one of the things I referred to a little bit earlier is that we know a challenge with students that struggle academically is that you have to stick with it a lot longer and work harder sometimes. And students need to practice numerous times. So it's really important to help students focus on persistence and the effort that might be necessary and help provide them with some motivation and engagement. We know that students with math learning difficulties have trouble beginning and persisting with problem-solving tasks. So we can think about how do we help them start and stay with a problem. That's going to really help them. We also know that student attention is one of the most persistent child level predictors of whether or not they will respond to an intervention for whole numbers. So we want to think about these self-regulation tasks and opportunities. We want to help students become aware of how they think when problem solving. We want them to use heuristics and mnemonics and verbalization, so those think alouds that you were modeling earlier, to plan, monitor, and modify their work. So you're actually teaching them that process. And you can do that through metacognitive strategies. I'll show you one example in the next slide, which we know that metacognitive strategies improve math problem solving of students with math learning difficulties and disabilities. So one of those opportunities is by having checklists to help guide self-regulation. So this is a very simple checklist. It comes from the IRIS Center. If you haven't checked out the IRIS Center, it is a great resource. And the process of self-regulation is having the student go through the questions. They consider the task at hand and what is required. So it's very helpful to have a checklist for them to actually engage in that self-questioning component. Then they're going to say a statement to themselves, such as, okay, read the problem. I read the problem. I'm going to ask myself, what is the problem asking? That would be an example of self-instruction. Monitoring their own performance is actually being able to check off each of these steps that they followed through on them. And then self-evaluation is going back and checking the work and correcting their errors. We also can work to provide meaningful feedback that is timely and useful to students by reinforcing effort, persistence, task completion, and skill improvement. And we can do that through praise, by having students score their own work and chart it, by giving them choices that will help them engage in their lessons themselves. They can make choices in terms of, we want to make sure we know the instructional strategies we're using and that they're all equally supportive of the student. And then they can decide which ones they use or which activities they engage in that day. They can reflect on goals that they've set for themselves. And they can also do something like a ticket out, 3 things that I learned today. When working in groups of students, it can also be really helpful to facilitate teamwork, mutual assistance and encouragement, and commitment to the pro-social goal of working on math and only math. And we know that math achievement is actually improved by enhancing motivation and making students active learners. So adding things like a token economy or a group contingency, a behavior contract, or a mystery motivator to our group session itself to make sure students continue to be engaged in that session and helping each other out in that session can be really useful. We used to use the an adaptation of a game called What I Need, or and it would actually, it's a good behavior game adaptation. And so it would be the teacher versus the group of students and how many points they can earn in showing that they're engaging in that math activity and task. So that is dimension 1, adapting the intervention, adding, altering academic components, and then adding behavior supports and self-regulation strategies. Number 2 is increasing dose. So talking about dose is one of my favorite things. One of the things that we know is that Dose represents session length, frequency per week, and total duration, but we don't always in school have control over all of these factors. And that time is one of the most precious commodities in school. So the general guidelines that came from IES on math practice in 2009 were that there should be about 20 to 40-minute sessions, 3 to 5 times per week for 8 to 12 weeks. So we're going to talk a little bit about that because what I have observed in schools is that 20 to 40 minutes is about all that is available in schools. So that may be fixed, that session length itself. But I've also observed about 2 to 3 times weekly intervention delivery. So maybe that's something, the frequency per week, that we can address. And we can also extend the treatment duration, particularly if you're noticing the student is making progress towards that benchmark. The 8 to 12 weeks probably isn't very realistic, or might be realistic, but only for some students. So we know there's this tendency to hold on to the idea we can address student learning needs in that fixed period of time. And I think we should probably abandon that idea. We also know that schools tend to offer 1 intervention session per day for all student concerns. And that's problematic because it means that schools are choosing whether students receive reading or math or speech or counseling or social skill training in that 1 session. So we also want to think about how are we embedding our intervention sessions into our math blocks in order to make sure that we have an opportunity potentially for daily intervention services. When we think about the total duration, the data suggests that when we're describing students with those large gaps between expected and current performance, that intervention durations might extend over months, if not a couple of years. So that 8 to 12 week period, we need to think about more flexibly. So we'll start with total duration. We don't have a ton of data on how to arrange intervention sessions looking at that total duration in math. We do have some evidence from reading that indicates that initial scores can help indicate how much intervention might be needed. For example, if you have higher oral reading fluency scores, it might be the shorter intervention time that's needed. If you have lower oral reading fluency scores, you might need a longer intervention time. And then at the secondary level, again, in the area of reading, we see that secondary students often need 2 years of support in order to catch up. And so we want to think about what that total duration looks at and think about that more flexibly. The thing that I think allows us some opportunity is in the frequency per week. And in math, we have some preliminary data to illustrate that more sessions per week is better. So 4 to 5 times weekly should really be the aim. We were able to provide in one of our studies the same intervention either once per week, twice per week, or 4 times weekly, and total time each week was held constant. And we showed that 4 times a week is better than 2 times or 1 time weekly. And there's also a meta-analysis on math interventions that show the frequency of sessions impacted intervention effect size. So here we're thinking more often per week might be a really good way to maximize opportunities for students who are struggling. And then in terms of session length, it's helpful to think practically. As I mentioned, we are often restricted to 30-minute sessions, so we need to maximize that time we have available, which means that if we have shorter sessions, the intervention needs to maximize those active ingredients and opportunities to practice, those things that we know will impact student outcomes. So that's dose, right? That's pretty simple. There's some variables that we're able to change in schools. There are some that we are not able to change in terms of time allocated to us. The third dimension is changing the assistance. So this is really about matching the skill needs of a student to instructional approaches. Often it's not the instructional strategy, it's the application of the strategy. So for example, an instructional strategy should align with student needs. So in all of these cases, we might be using manipulatives, but we might be using them at the wrong time. We want to make sure we're using manipulatives when students are first learning a new concept or skill. We want to make sure we're using timed activities only after high accuracy is demonstrated on a skill. We want to be using games when students are accurate and fluent with required skills because games are really opportunities for generalization. And then we want to deliver challenging novel problems only after prerequisite skills are mastered, because this is really an adaptation activity where students are taking what they know and using it to adapt to another problem. So we need to make sure that they have mastered all the prerequisite skills required. And we can think about that using the instructional hierarchy. The instructional hierarchy, which is sometimes referred to as the learning hierarchy, is a heuristic that allows us to match instructional strategies with the stages of student skill development. And we think about skill development in these stages: acquisition, which is establishing a skill or a concept, so building accuracy; fluency, which is really about remembering and retaining those skills and concepts, so it's about efficiency and accuracy; generalization is about enduring, that the skills and concepts are demonstrated across academic tasks and situations; and then adaptation, which is applying those skills and concepts that are integrated and applied to novel problems. Sometimes people talk about generalization and adaptation as sort of one box. We can find students' stage of skill development using our assessment tools and match it to the corresponding instructional strategies that they need. And this is really an opportunity for us to individualize in a really effective way. We can use that. We can find students' stage of skill development. We often use curriculum-based measurement, particularly for computation, where we have those tools available, and match it to those corresponding instructional strategies. This graphic itself was created by Corey Peltier and is a good illustration of how skill development stages match with teacher instructional strategies. So if a student is showing that they're frustrational in a skill, they're really building acquisition. And so we need specific strategies that will help them build that acquisition or accuracy. If the student demonstrates that they're instructional in this particular skill, then we should see that students are accurate in their performance, but they might be slow. So we want to actually focus on building fluency with that skill. And that's going to require a different set of strategies instructionally. And then lastly, if students are at the point of they're accurate and they're fluent and we need to see them demonstrating mastery, we want them to generalize those skills. We want those skills to endure over time and across different situations and tasks. So the focus would be on generalization at that time. So for example, I like to think about if students are slow and inaccurate, we are going to implement explicit instruction with modeling, guided practice, and immediate corrective feedback. That's for students in the acquisition stage. If students are displaying slow but accurate performance, we really want to help them develop fluency with opportunities for productive practice. So that's the fluency stage. And then we may see a couple of different patterns for students in that generalization stage. They might be accurate, efficient, and quick, but they're not demonstrating those skills in more complex problems. Or they may have previously demonstrated that accuracy and fluency, but it's inconsistent, their performance. So in that case, we might want to target self-monitoring and self-regulation, improve student attention and focus. So again, by thinking about how students are responding to our skill development, or where they are in the stage of skill development, we can actually match them with instructional strategies. It is flexible with our assistance, and the strategies help to move the students forward. So this is a further demonstration of what you would do if a student is in the acquisition stage. The emphasis here is on immediate feedback that can improve a learner's confidence, self-awareness, and enthusiasm for learning, which of course leads to increased motivation. We want to provide them feedback at the time of learning that helps improve understanding, address misconceptions, reinforce strategies, and support retention in long-term memory. And we want to promote accurate reasoning, which necessitates demonstration or modeling, narrowing of the curriculum scope, and high rates of feedback with reinforcement. So we are just going to focus on that modeling, demonstration, prompting, and cueing, and immediate feedback to build that skill. For fluency, we want to build efficiency. We want to help the student retain the skills, and we're just going to provide them lots of opportunities for brief and frequent practice. And we want to use timed and peer practice, give them feedback on that fluency, and help them start to engage in self-monitoring, reflection, and graphing. Generalization is about that transfer across tasks, activities, problems, and consistency in their problem-solving skills. So we want them to be able to solve problems multiple ways. We can use team-based activities, math games, and we can interleave practice, which is the process of mixing up the skills that have been previously practiced so that students can select strategies. Okay. So those are our first three dimensions. We are now focusing on adjusting those target skills. When we think about adjusting target skills, that's our fourth dimension, we want to think about smaller slices of the curricula, so focused and specific goals. We want to think about teaching prerequisite skills, and we also want to think about how much content we are giving to students at the time, so reducing that set size. I've adapted this example from Sarah Powell. It's one of my favorite things, which is looking at foundational skills by climbing a mountain. In this example, we're using Common Core standards. You can use your state standards and apply the same idea. So what you see at the top is this Common Core cluster, and it's a grade 3 operations and algebraic thinking. And what we want to be thinking about is as students hike up the mountain, they reach a series of base camps or foundational skills, and they gain their supplies, which are necessary for them to reach the top of the mountain. So in this case, the supplies are the skills. When foundational skills are integrated, they lead to mastery of that cluster skill. So in this example, represent and solve problems involving multiplication and division. I've just simplified this a little bit for the purpose of illustration, but we can see students need to be able to interpret 5 times 7 as 5 groups of 7 objects, interpret 35 divided by 7 as 35 objects partitioned into equal shares of 7, determining the unknown number in a problem that is 5 times question mark equals 35, right? They need to find the missing part. And then using multiplication and division within 100 to solve word problems. So really thinking about what your skill sequences are and how you're building each of those foundational skills to get to that ultimate goal. When you think about building skills to get to the top of the mountain, you naturally consider skill sequences. So you might think about how those are mapped in your school or district and what sources you can use to help you. So remembering not all skills are equally important is really helpful when you're thinking about these skill sequences. There are key skills that we need to know in order to be algebra ready, and that's what you really want to focus on in K-8. So you want to think about things that we already talked about, like basic numeracy skills, number operations, and word problem solving, which are 3 really big buckets that are key across whole number knowledge and then rational number knowledge. Whole number knowledge being the emphasis when we're talking about K-5 instruction. So in this example, I'm just illustrating to you, okay, if we're thinking about early numeracy skills, we might be talking about number naming or counting objects, quantity discrimination, or missing numbers, so knowing where the number goes in the sequence. Whole number operations, sums to 5 to 10 to 20, minuends 5, 10 to 20, fact families, 2 by 2 digit with and without our grouping. And then when we think about rational numbers, we can talk about placing fractions on the number line, quantity comparison with like denominators, adding and subtracting mixed numbers with like denominators, etc. You can find these skill sequences through Achieve the Core. You can also find them. This is an example that I have on the slide from Amanda Vanderhayden, who often provides them for free on different websites related to her Spring Math tool. Brian Ponce has some on his Mind website. So there's lots of places to get these skill sequences, but it's also really helpful to talk to the grade above you to identify what are those key skills to make sure that that's part of your skill sequence too. In addition to really thinking about those skill sequences for your intervention delivery, we also want to think about how much content we are giving to students at a time, and do we need to reduce that content? So as set size increases, the magnitude of an intervention effect decreases, which simply means that when you provide an intervention to a student that is struggling, and you, for example, are teaching them all of the multiplication facts that are available at the same time, the effectiveness of your intervention approaches may decrease because you're giving them too much content. So you want to think about the number or amount of targeted content. In another example that again came from Matt Burns is that he illustrated that the best retention was around 4 facts, just looking at facts as the proxy for a piece of information in this study. So you want sort of something in the middle, not too little, not too much, because you don't get that same retention. And so working with your students and identifying what that is going to be useful and sometimes necessary in order to help make student gains. So also you want to think about the sequence of that content. So are you targeting, as I just mentioned earlier, the entire set of facts, for example, addition facts, Or does the student only miss the sums over 10? If the error pattern is sporadic, then you can order the missing problems according to the easiest to hardest to practice a small set to mastery first before moving on to the next harder sets. And then you can promote generalization later on by using cumulative review. And so we know that, for example, plus and minus one are easier, and harder is finding that missing number in those non-traditional equations. And the last thing we're going to be talking about is changing grouping. Changing grouping can be challenging, but there's also a lot we actually know in math about grouping. And so I want to share that information to you because I think it means that we can provide efficient and effective service delivery to students with our small groups. And again, goes back to the idea that we started with, which is intensifying intervention is not about providing one-on-one service delivery. It's individualizing supports based on student needs. So here's what we know in math. And the data and reading are fairly consistent to this as well, which illustrates that small group and one-on-one tutoring result in similar outcomes or even sometimes favor small groups. So that's, I think, good news for all of us because it means we can provide services to students more efficiently. What we know about in math is that small groups of two tend to provide higher quality teacher-student interactions and more opportunities to practice. So if a student is needing those two pieces of active ingredients that we've been talking about, small groups of two are better. However, small groups of five provide more opportunities for peer discourse, which is also important. So thinking about what your student needs and aligning that with the group size might be helpful. There's also some really interesting data that Sutherland and colleagues have identified around what the skill needs are of the students in the group. So a smaller homogeneous group of two is going to outperform a group of five, even if that group of five is homogeneous as well. But what's really interesting is looking at that variability in students' skills. So it means that we really need to take the time, as we talked about earlier, to engage in that diagnostic assessment to understand what students know and don't know and match them accordingly. If we are able to do that, we can provide service delivery to students in larger groups if the skills that they need are very similar. If the skills that students need that we put into a group are very heterogeneous, then we need much smaller groups. So it's important to group by skill strengths and areas for improvement to identify more homogeneous groupings. If you can't do that, then you're going to need to form smaller groups. So I think that's a really important practical finding. And it gives us the idea that we can spend more time thinking about that assessment and what the student needs before we deliver the services. Because once we deliver those services accordingly, they're going to be much more powerful. We also know from the math literature that the intervention provider credentials are not a significant predictor of outcomes, student outcomes. So meaning you can be a certified teacher or a paraprofessional as long as you have the appropriate training, consultation, and support in order to deliver the intervention as intended. And then, of course, we're talking about now adapting that intervention. And we also want to make sure that we're supporting grade level concepts while we're building foundational skills. So in summary, I'm going to summarize the 5 dimensions that we are talking about, and then we're going to apply them. And that's going to be the last part of our session. So hopefully you'll bring all of this together for you. So first, we can adapt the intervention, add, alter academic and or behavior supports. Second, we can increase or alter the dose. We're talking about session duration, frequency per week, or total number of weeks provided to students. Third, we can change assistance or matching instruction to the instructional hierarchy. Where is a student skill development and how do we match instructional strategies accordingly? 4, we're going to adjust the target skills. This can be really important. We're going to slice back, meaning we're going to focus on prerequisite skills that are missing, and we're going to break it down. Small pieces of information at a time and consider how much information we're providing in any given session. We want to think about then making sure students master that content that we provided before moving to the next bit of content. And then 5, changing groupings. So having smaller group size or regrouping students by similar skills. So the last part is how do we make this happen? So again, these 5 dimensions that we just referred to, we are going to look at each of these dimensions using some data. So I'm giving you just data that I just made up and created these scenarios and trying to talk through with you how what the data look like will match to how we consider each of these 5 dimensions. So in this case, this is back to Hayden, the original graph that I shared with you earlier. This is our sample case. So we can begin by asking ourselves, how is a student performing? If we look at the aim line, which is represented by that teal dashed line with a star, we can see that the student is not making progress. And that's meaningful compared to where the student was without any standard protocol of math intervention. So we're going to first assume that there are no issues with absenteeism or intervention integrity, because if those are part of the challenge, those have to be addressed before we can actually engage in this process. So we're assuming no issues with absenteeism or intervention integrity. So we are going to think about, should we adjust the target skill? Have the prerequisite skills been mastered? Is too much material being presented at once? Should the task be altered such that concrete representations are utilized? So the 5 dimensions that we want to talk about: adapt the intervention, increase the dose, change the level of skill, adjust the target skill, or change the grouping. All 5 could be altered in this scenario because the student is making little to no improvement. So how would you choose? Well, you can collect more diagnostic data to make those choices. Changes might include, and so I've given you specifics on the right-hand side of your screen. You can evaluate the intervention and consider providing more opportunities to practice or more systematic explicit instruction. You could add motivation and self-regulation tactics. You can think about increasing session frequency and total duration of the intervention, assuming that you can't change how much time you have per day. You can provide more support or assistance by modeling and demonstration, more guided practice. You can assess and teach prerequisite skills or reduce the set size per session, or reduce the group size. Say the student was in a 5-to-1 group and you might move it to a 2-to-1 grouping. So all 5 are on the table when students are making little to no improvement. And how you're going to know is by looking deeper into the data that you have about that student and their progress to see which of these are the most viable choices to make. The next one is slow improvement. So you can see there's a difference in this graph in terms of what does it show you about performance level and growth, and how do we think about what dimensions and options will work best. So you see here that the students, the blue markers, are making progress, and they are in a similar path to that orange line, but they're not on the orange line, which is where we want the student progress to be. So we want to speed up sort of that progress, if you will. We are going to make different considerations for this student. In this student, we want to think about adapting the intervention and increasing the dose because the student is already making progress. So again, on the right-hand side of your screen, you can see options for individualization. Add strategies to enhance opportunities to practice, alter the time allocated to intervention components so that more of it's on fluency building and generalization. You can add self-regulation and motivation strategies by using self-monitoring, charting, goal setting, or reinforcement and choice, and increase session frequency. If you're only delivering 2 to 3 times a week, deliver 5 times a week. So we are talking about 2 dimensions here and different aspects of those 2 different dimensions that we can adapt and alter. Now, how does that look when a student is making expected improvement? I think this is really important because we sometimes forget about this when a student started out slow, low, or absent in terms of their progress, and then they start to make progress. So in this case, the aim line and the data path are on top of one another. So here you could decide not to make any changes because the student is making the progress that's anticipated, or you can think about changing assistance, which is our 3rd dimension about the instructional hierarchy. You might think about making a more independent focus on generalization, have them do more independent work or assistance. And then lastly, what happens when their student performance exceeds the goal? So here you see that the blue data markers are above, and this shouldn't be reading performance, that should be math, Sorry about that. Um, the blue data markers are above the gray line. And so what we're seeing here is we want to adjust the target skills, fade the frequency of sessions, and remove the intervention and monitor. So the two dimensions to consider here again are adjusting that target skill or thinking about the dose. So fading the amount of sessions that we are using. So again, in summary, these 5 dimensions allow us opportunities to make adjustments based upon data. So we've talked a lot about adapting the intervention, which I think is going to be a really important component of what you're going to engage in. Changing assistance, so matching instruction to the instructional hierarchy, adjusting those target skills, so slicing back and breaking it down, or changing those groupings, and thinking about how those groupings are made from the beginning. I have a star here on increasing dose because one of the thoughts that you might consider is starting with a really high dose of intervention for the students that are struggling the most and not being responsive. So thinking about delivering the intervention program daily for at least 30 minutes might be a good way to go. And then you removed that as a potential reason for students not making progress. And that leaves you with 4 options for intensification following that. And the reason we say that increasing dose is really important is because likely students are not getting enough of the intervention dose in schools based on some of the limitations that we already know exist. So how can you manufacture it so that students get the right dose first? And then from there, that narrows down the choices you need to make when you're looking at students that don't respond.